I'm Anil Kumar, and in this particular video, we will combine the 7 properties of limits with our basic limits, right? So I have basic limits separately listed out as I explained earlier also. Basic limits for us are the limit for a constant, which is limit when x approaches a for a constant c is c, right? So that is for a constant, correct? Where c is a constant. So we are talking about constant function c, right? This is the first basic limit for us. So we'll just say 1 and 2. The basic limit is that limit of x as x approaches a is equal to a, right? So these are the two basic limits. I hope you understand what we are trying to say here. So when we say the first constant, let's say constant number could be 2, 3, 4, anything, right? So if I have a constant function, then it's a horizontal line. The horizontal line represents the constant. Let me take a function, constant function. For example, let us say pi, and that's an interesting constant function. Pi value is approximately 3.14. And you will see that any point A, right, the value is pi. Do you understand? It is always pi, the same as the function defined, correct? So that is what we mean from the first property, correct? So we took a specific example. It could be 1, 2, 3, 4, 0, 9, whatever. So we always see that limit of a constant is same whatever value you approach, correct? You approach any value, the function value will remain pi in this case, correct? Now the second example which I have taken here is a limit of line x, right? So x means a straight line which divides the coordinate system into equal halves diagonally. Now here also what you observe is the function here is f of x. Let me write down here, f of x equals to x. So limit of this function as x approaches any value a, right, is actually equals to a, right? If the function f of x is equals to x, then the limit is a, right? The value which you are approaching. So that is our second basic limit. Now using these two basic limits, we get other limits which are very helpful to find limits of our other functions, correct? So one of them, we'll begin with these two, 6 and 7, and we say, well, what is the limit when x approaches a for a function which is x to the power of n? Now using this property, it says that limit of function to the power of n is whatever its individual limit is. So the individual limit is, in this case, limit as x approaches a of x, right, to the power of n. So we write n here. Now as we have seen here, limit of x is a, so we could write this as a to the power of n. So I hope now you understand that we could treat this as one of our basic properties, or derived from the basic properties, that limit of x to the power of n as x approaches a is a to the power of n, correct? Similarly, we could use this property and also derive another important expression, which is limit as x approaches a for nth power of x, correct? So from this rule, it is limit. So we'll write here the outside limit of 1 over n, correct? And inside limit of f of x when x approaches a, f of x is x, right? So it is limit of the function x in our case, right? Because f of x is x for us, to the power of 1 over n, and we know limit of x as x approaches a is a, and therefore we get here a to the power of 1 over n, correct? So that is how we can combine these properties with the basic limits and get limits for all other functions, correct? Now in following examples, I will use the sum of limits, product of limits, difference of limits, and all these, and just take a few examples. But I feel that these two are also as basic in nature as the two which we had been considering. So in our examples which follow now onwards, we will actually have combination of the basic limits and property 6, 7, right? Or we say as the case may be. So when I use that word combining with our basic limits, we'll treat these four as the basic limits. I hope you can understand that part. Thank you and all the best.